So now that we know what permutations are, in the last video we saw how to do permutations if we are going to arrange everybody in the group or all the objects in the group. In this video, let's look at what happens if we only take some of the objects. So consider if there are 20 students in the class and any four of them I should say, any four of them may be asked to give a report on a given day. For the first presenter, there are 20 choices. For the second, there are 19. For the third, there are 18. And for the fourth, there are 17. So let's think about that. For the first presenter, there's 20 possible students to present. Let's do that in red. So there's 20 different outcomes for who's going to go first. Once we've picked that first person, there's 19 people left for the second presenter. So we'd have 20 times 19 possible outcomes for the first two presenters. Once they've gone, there's 18 people remaining for the third presenter. So the first three presenters could go in any of 20 times 19 times 18 possible orders. And once they've gone, there's 17 people left for the fourth presenter. So this is different than the previous example because a couple of things. One, that's going to make a big difference here, that 17. In the previous example, the last person didn't make a difference because there's only one option left. But there's a lot more options at each level, so they're going to have significantly more possibilities here. If we were to type this in the calculator, we would get, it actually ends up being 116,280. So lots of different ways for those first four presenters to go, but let's explain how this is tied with permutations, right? This is a set of different arrangements or different orders that could happen. So maybe it's Pete, then Jim, then Sarah, and Michelle, right? Or maybe it's Pete, then Sarah, then Michelle, then Jim. Or maybe it's Pete and Jim and Michelle and Sarah, and so forth. So you have all these different arrangements that could happen. 116,000 different arrangements. So symbolically, we can write that in permutation notation as saying, well, there were 20 objects, right? 20 objects or students, and we were going to arrange four of them. So this would be 20p4. And what we see is that 20p4 is exactly equal to 20 times 19 times 18 times 17, right? From above, that's what we see. 20 arrangements of four objects is 20 times 19 times 18 times 17. Well, if we think about this a little bit awkwardly here, I'm going to overcomplicate it for a minute to see how this formula can work. Really what we did is we did 20 times 19 times 18 times 17. I could say that I actually did multiply this by 16, by 15, and so forth, but then divided out the 16 and the 15 and the 14, right? This would just be repetitive things that I'm canceling out. Well, if I thought of it that way, then the numerator was really 20 factorial, 20 multiplied all the way down to 1. So 20 factorial would be my numerator, divided by, in the denominator I had 16 factorial. So I really could think of this 20 times 19 times 18 times 17 as 20 factorial divided by 16 factorial. Okay? Or in general, if we see what I actually did there, is what I could say is NPR. If I have some group of things and I choose some other subset of them, this is equal to that first number n factorial divided by, the bottom was really the number of total objects minus the number that I selected, right? I did 20 minus 4 is 16, and that was my factorial in the denominator. So I took the total number of objects minus those that I selected and performed the factorial on that difference. Okay? And this is our general formula for computing permutations. Okay? You're always pretty much going to have a calculator handy, so I don't know that you really need to memorize that. It's handy. It can help you do things faster if you know how to do that in your head, but generally speaking, you're going to have a calculator, so I don't know that you really need to memorize that, so maybe we don't need that star there. But you definitely need to know how to compute permutations and set permutations up and know the difference between permutations and combinations when we get to those later. Let's look at an example. Oh, actually, sorry. First, let's see how we can do permutations in the calculator. Okay, so in the Inspire, it's pretty simple. We go to Menu, Probability, and right there it is, Permutations. Okay, and so it says NPR, and we need to list the two numbers involved here. We need the total number of objects, and then a comma, followed by the number of objects that we selected. So 20P4, it's a different presentation, but it's the same meaning, is going to be that 116,280 that we saw. Similarly, in our scientific calculator, okay, we can do probability, and then we choose choice 1. And as you can see here, they want the number in the front to be in front of the NPR. So we would say 20, then do the NPR computation. So your scientific calculator might want it this way as well. You might need to do the number first, then enter the command. But 20 NPR4 is going to give us the 116,280. Okay, so make sure you know how to use your calculator to compute permutations. You don't have to do it by hand, but you do need to know how your calculator does it. And in the next video, we'll just look at a couple more videos here and see how permutations work.